in this lesson, we're going to learn how to solve radical equations. Now, whenever I use the word radical, what I'm talking about is roots. So typically you would think of square roots, but you could also have cube roots or fourth roots or fifth roots and so on and so forth. For our first example, we're going to learn how to solve just a very basic square root equation. So we've got the square root of 4c minus 3 plus 9 equals 12. And what we're trying to do here is we're trying to solve for c. Now, this is just like solving any other equation. The goal here is to isolate the variable so that we can know what c equals. So basically, we're going to get rid of one number at a time until the only thing left is just c. So if you look over here at the left-hand side, we're going to work our way from the outside in. So the first term I'm going to get rid of is this plus 9. Now, just like always, to get rid of something, you do the opposite. So if this is a plus 9, then what I'm going to do is I'm going to subtract 9 on both sides, because 9 minus 9 cancels out, which leaves us with just square root of 4c minus 3 equals 3 over here. 12 minus 9 is 3. Okay, so now we're going to do the same thing again. We need to get rid of the next operation. So see how the square root is kind of holding everything together? We need to get rid of that square root. So we know that the opposite of square rooting something would be squaring it. So we are just going to square both sides. Now, if you square a square root, it cancels out, which would just leave us with 4c minus 3 equals 3 squared. 3 squared, 3 times 3 is 9. So continuing on to get c by itself, next up I'm going to get rid of that minus 3. So I'm just going to add 3 to both sides, which gets us down to 4c equals 12. And last but not least, to get c by itself, we'll just divide by 4 on both sides, which gives us our final answer, c equals 3. And just to show you that this works, I'm going to plug that 3 in to the original equation. So this would be square root of 4 times 3 minus 3 plus 9. And if we did this right, then it should come out to equal 12. So right here under the radical, 4 times 3 is 12, minus 3 is 9. The square root of 9 is 3, and 3 plus 9 does in fact equal 12, so we know that our answer was done correctly. This next equation is also a square root function, but it's a little bit different. Here we have square root of 7n plus 15 equals n plus 1. And again, what we want to do here is solve for n. We need to isolate the variable. The difference is we have an n on both sides of our equation. We can't exactly move the n's all to one side because over here, these are locked underneath the square root. So what we really want to do first is we want to cancel out that square root. So like we learned on the previous slide, the opposite of a square root would be to square it. So if I square both sides, this side, the square, cancels out the square root, which leaves us with just 7n plus 15. That's easy enough. The other side is the side that's tricky. Over here, we have n plus 1 squared, which technically would be n plus 1 times n plus 1. So what we need to do over there is we need to multiply all of that together. So on the left, I'm just going to bring this down, 7n plus 15. But on the right-hand side, I need to distribute this. So we're going to go through and multiply the whole thing out. N times n is n squared. N times 1 is 1n. 1 times n is 1n. And 1 times 1 is 1. Okay, so we multiply it all out, and now I'm going to clean things up a little bit. I'm going to come over here and combine like terms. So this would be n squared. 1n plus 1n would be 2n plus 1. Okay, so what we have now is actually a quadratic equation, and as soon as you see that n squared there, what you want to do is you want to think about factoring. But you got to get everything to one side before you can factor it. So we're going to take the 7n plus 15 and we're going to move it all over to the other side. So I'm going to do minus 7n over here. Make sure you stack those like terms. I'm going to take the plus 15 and I'm going to subtract 15 from both sides. So now everything's on one side. There's nothing left over here, so that's going to be 0 equals n squared. See, 2 minus 7 would be negative 5n. 1 minus 15 would be negative 14. So we've got n squared minus 5n minus 14. Now that we can factor. So factoring, I know I'm looking at an n times n to get that n squared. And then I'm thinking about what multiplies to negative 14 and adds up to negative 5. What multiplies to negative 14 and adds up to negative 5? That would be negative 7 and positive 2. Negative 7 plus 2 is negative 5, and negative 7 times 2 is negative 14. All right, so we've gone all this way, and we're still not quite done yet. We do still have to solve for n. So remember, with factoring, this thing is set equal to 0 for a reason. We need to set each factor equal to 0 so that we can figure out what exactly n is. So it's going to look like this. We're going to have n minus 7 equals 0. We're going to have n plus 2 equals 0. So if I solve for n now, over here on the left, n minus 7 equals 0. I'm just going to add 7 to both sides. So that's n equals 7 for my first solution. On the right-hand side, I have n plus 2 equals 0. If I subtract 2 from both sides, I end up with n equals negative 2. Now, these are my solutions, but like I did on the previous one, I want to check my answer. So let's see if the 7 works. So I'm going to come up here, and I'm going to plug in the 7. So that would be 7 times 7 plus 15 equals 7 plus 1. So I'm just going through the original equation up here at the very top, and everywhere where I see an n, I'm plugging in 7. So let's see, this would be 7 times 7 is 49, and 49 plus 15 is 64. And over here, 7 plus 1 is 8. Now, is that true? Is the square root of 64 equal to 8? Yes, it is. So this answer works just fine. Now, let's go through and try the other one. So I'm going to plug in a negative 2 everywhere that I see an n. So again, back to that original equation up here at the very top. I'm going to do 7 times negative 2 plus 15 equals negative 2 plus 1. So I'm just going through and plugging in that negative 2 everywhere where we see n. All right, so here I've got 7 times negative 2 is negative 14 plus 15 is 1, and negative 2 plus 1 is negative 1. Now, if you type this into the calculator, the square root of 1 is positive 1, not negative 1. This one actually doesn't work, and we've seen this before in previous units. If you plug in the number and it doesn't actually work, that is called an extraneous solution. It's an extra answer that you get when you solve, but it doesn't actually work when you plug it back in. So it will be very important for us to go back and plug in our answers to make sure that they both work, especially if you get two solutions.